So obviously these are simple examples, but what I'm trying to suggest is you want to have certain control over your deployments, and in particular you want to control whether the application instances of two versions may coexist, even if it's just for a short period of time, because there could be incoming requests, or whether they shouldn't coexist. So let's look into the details of that with a little, a few experiments. So as you can see in the example of replica sets, it always makes sense if you have a question just to make a little and conduct a little experiment and see how the system behaves. So let's create a deployment. So if you look up Kubernetes deployment, you'll come also to the Kubernetes to Kubernetes documentation. There are also examples. So we create our deployment here. As you can see that here's the API version is called extensions and v1 beta. It's because I used an example that was rather old. This will be fixed in the tutorial pretty soon. So the right API version to use is this one. All right, so we call that application Gamma. It's arbitrary name. There's no special meaning to it. Replicas is set to 1. Well, let's set it to 4. And we call that blue. So I've created the deployment YAML, but we don't need the replica set that we've created earlier. So let's kick the replica set. It will be this one. So the pods should be gone, or yeah, they are terminating. So the reason why I'm doing this is because we can use the same service, the same ingress, and we hijack the two by using the same label. Do you remember how a service connects to the application? It uses the label. So if we are looking into the services, simple go web. There's an example for the service, so we can go with another service. It's also fine. All right, so yeah, we can deploy this and apply it. It's a deployment, which is a new kind. It's not a pod, it's not a replica set, it's something new, it's a deployment. The name is called app Gamma. Replicas is 4, and we're using the blue version of our application. Get deployments. You can see that scheme always works. Like you have kubectl get, kubectl destroy, kubectl apply, kubectl delete, and then the kind of object you want to modify or create. All right, so you can see there are 2 or 4 ready. Now there are 4 ready, and we kubectl describe the deployment because that always gives us a hint of what's behind the scenes. All right, so let's start from the top. Namespace is our Kubernetes training namespace. We have a label, which is app is equal to app gamma. There are some annotations, for example, well, this is a deployment, Kubernetes, and it has a revision. So that already suggests, oh, the structure is somehow aware of changes, because a revision refers to a change. So the replicas is 4 desired, 4 updated, 4 in total, 4 available, and 0 unavailable. The strategy type is a rolling update. So the rolling update strategy is exactly referencing to the conversation we had earlier. It means that during an upgrade of the deployment, you basically have a number of 4 pods. If you have one version, currently it's blue, there are 4 pods as replicas for this application. Now, if you want to change to green, what it does, it takes out a pod or a number of pods. You can specify an in-flight limit here, but let's stick with in-flight is equal to 1. So you switch off one blue pod and switch on one green pod. Then you switch off another blue pod, you switch on another green pod. So which means that you'll basically ramp this one down and this one up. And this is what I mean. During that ramp up and ramp down phase, during that crossover, so to say, instances of both applications coexist. And this is what the rolling update strategy will do. So as you can see, there's also a recreate strategy, and this recreate strategy will not do a crossover, but it'll do a switching off of all the 4 pods of the old version, switching on all the new versions of the green version. And why is that necessary? It's because in some cases you cannot tolerate for those applications to coexist because they would fail or do otherwise harm. So you can control this and you can do something about it by changing the deployment strategy. But be aware that switching off your application instances will create a little downtime. All right, so here's our deployment blue. We kubectl get our deployments. And now it's the interesting thing to read on. So we have a rolling upgrade strategy, 25% maximum unavailable, which for 4 replicas means 1 could be unavailable. If we go to 8, a 4th would be 2. So then it would already take down 2 pods at the same time. You can specify that. So containers, here are our containers, port 80, this is business as usual. Here's the interesting part. It's scaling the replica set. So somehow it refers to a replica set. Here it says old replica set none, new replica set, app, gamma, and this number here. Well, let's copy it and look what happened. Kubectl get replica sets. And here you can see that the replica set name contained in the deployment is equal to the replica set we can see here. So which basically means that the deployment uses a replica set as its means. So in order to create pods, the deployment doesn't create pods itself, but it uses the replica set. As we have seen, the replica set did not really respond to a changed container version. Instead, it didn't recognize the changed container image in the template specification for the pods at all. Once we deleted one of the pods, it created a new version of the pod with a new container image. suggesting that the replica set controller only looks into the specification when it has to perform the job of healing something. So it observes the number of replicas and matches that ongoingly, but it doesn't do a deep equal. So if the deployment is the way to do that, let's see how the deployment then responds to such a change. But before we do that, well, let's create a service first. So I think it's good to have an ingress too. So here we got our service. So we have a different selector here. The selector is app gamma. Despite of that, it's just a simple service. So let's create this one. We could also have hijacked the other service easily. All right, so we got a service. Here it also creates an ingress. So, but we don't have to create a new ingress. We just use the one that we already have. kubectl get ingress. So we take this ingress, edit ingress, so here we have a service name. We first check what the application does. Currently it's temporarily unavailable because there's no service existing. So the backend is empty. So you get an Nginx 503. So remember that the ingress controller here is an Nginx. So this also gives you the hint on which level this one fails. It fails in the ingress. So the ingress is the Nginx. The Nginx doesn't have a backend, so it provides you temporarily unavailable. So let's give him a backend that actually exists. And here we go. So as you can see, we've thrown away the replica set. We've also thrown away the replica set service, which we could also have reused by changing the label. But in this case, we've created another service and we've reused the ingress. And we've reused the ingress by changing the backend. And in the ingress, we are not using a label, but we're using the name of the service. So far, so good. We have an application. This has 4 blue instances, so we can reload as often as we want to. We'll always get the blue version. So let's take the deployment. And change this to green. So in a real world application, you would have changed the code, you would have created new container image, and now you have new container image with your new code. So this could, for example, be done with a CI/CD integration. You can create container images also without Docker files, and creating Docker files and building Docker files, for example, by using build packs, which is an alternative method of creating container images. But at some point you have a container image containing a new version, and we've updated our deployment description, and we'll now give it a try. So we have our ingress, we have the ingresses, we've ensured how it works.